Hi everyone, welcome back to the channel. This is Rosario Borgesi. Today I want to talk about lending and borrowing in DeFi, especially in the Aave protocol. We will explain how it all works, all its metrics, what you can do in Aave, and we will make a practical example using the application itself. So let's get started. Let's start with a basic example of how lending and borrowing works. Let's say that Alice has $1,000 and Bob needs $500. So Alice lends $5,000 to Bob and Bob agrees to pay it back with interest. But to avoid that Bob runs away with the money and never pays back its loan, Bob gives Alice a watch worth $1,000, let's say, which is the collateral. And if Bob repays, Alice gives the watch back. If Bob doesn't repay, Alice keeps the watch. This is a very simple example, but in reality, there is the bank that issues the loans. For example, in the mortgage, in the case of a mortgage, when you need to buy a house, the money gives you a loan, which let's say is 50% of the value of the house that you want to buy. And so the bank acts as a middleman to allow this lending and borrowing process. But since we are talking about DeFi, we have to make, in my opinion, it's important to understand the difference between a traditional and traditional lending and borrowing process and DeFi. So in the traditional process, as we said with the mortgage, we have a bank. So it is the bank that with its own money lends the money to the borrower. And of course, also in the case of the mortgage, there is a collateral, which, as we said, is the house itself. So the bank gives to the borrower 50% of loan, which let's say it gives a loan that is 50%, for example, the value of the house. If the borrower cannot pay the loan, the bank takes the house. But of course, where the bank takes the money, mostly from people that deposit in the bank. This is a simplification, of course, but these are the two main people that interact with the bank. So there is a group of people that deposit money into the bank. The bank loans the money to the borrower. Of course, the bank has to make some analysis on the credit risk and also has to comply with the rules and the regulations. In the case of DeFi, we don't want a middleman. We want to, in Web3, we want to remove the middleman here. So this process of lending and borrowing is handled by the DeFi protocol. So the DeFi protocol is set basically a smart contract that allows people who want to lend money, depositors, and people who want to borrow money to match. Okay, so differently from the bank that let's say lends its own money, here the DeFi protocol does not have any money. It's allows the match between people that are lending and people that are borrowing. Of course, in the DeFi, there are also some other actors involved, like the DAO, which basically is the organization that decentralized organization, autonomous organization that governs the protocol, makes the most important decisions. and this is also ruled by smart contract. And we also have liquidators, which are basically users or bots that liquidate risky position, so the protocol can be secure, can be solvent. This is a general view. Now let's see this in much greater detail. So we have the depositors in the case of traditional lending that put money in the bank, earn interest, but they have no control over how funds are used. They don't know what the bank is doing with their money. Then we have the bank, which is the middleman that holds deposits, lends money, sets the interest rates, approves or denies loans. How these loans are approved or denied? The banks makes credit checks, so it checks the credit score of the people, that person, the borrower that wants to borrow money. It also checks the income and job history and the personal data of the borrower. So, for example, if the borrower does not have a job that allows him to pay this loan, of course, the bank will not give you the loan. And of course, they will check your previous history. So if you haven't paid your previous loan, it will be very difficult to get a new loan back. And also there are, of course, rules and regulations, because you have to comply with the law, and there is also a government oversight over the bank. And the borrower is basically a person that requests loans, of course, needs approval from the bank, repays the loans with interest. So, in the case of DeFi, as we said earlier, there are depositors or lenders that deposit crypto. The funds go into a smart contract, so there is no middleman that checks your previous history or your personal data, or that can give you the loan if they like you or not. There is a basic the smart contract. There is a code that runs 24 hours over 7, and it already allows this matching between lenders and borrowers. So you earn interest automatically. And the DeFi protocol is based, as we said, on smart contracts, holds funds, issue loans automatically, calculates interest, and enforces the rules. The other, let's say, the other actors, as we said, in this game are the borrower. So the borrower can instantly borrow money, repays the money with interest. It has to ask no permission, and it locks the crypto as collateral. Then we have also the liquidator that can be bots or users. They repay risky loans, receive collateral at discount, and keep the system safe. We will see this part of liquidators better later on when we dive deep into Aave. And there is also the DAO. The DAO is a decentralized, autonomous organization that it handles the protocol governance, sets the rules and parameters for the protocol. For example, the assets supported, the interest rate, and risk limits. And it's based on token voting. So it is decentralized. There is no central authority that decides. You vote based on the tokens and on smart contracts. So why we want DeFi lending as opposed to traditional lending? Because we don't want to have banks or middlemen that approve our loans, but we want that this process of lending and borrowing money that should be open to anyone, just with an internet connection. There must be no credit score required. It should be transparent and on-chain, and it should be faster and always reliable, because of course the bank takes a lot of time before giving you the money. And of course we want ourselves to be in control of our funds, because we can see each time what our funds, where are our funds, while when we deposit into the banks we don't know the bank what is doing with our funds. So the most important protocol that we have in DeFi, in Ethereum especially, to that makes this lending and borrowing process is Aave. So for example, here this is a very simple example of how this protocol works. This protocol, as we said earlier, simply does not have money of its own. It simply matches people who want to lend money and earn an interest with people who want to borrow money and pay an interest. So let's say in this case, this lender gives to the deposits 10,000 USDC and gains 2% APY, while in this case we have a borrower that borrows $8,000 of USDC, but has to deposit a collateral of $20,000 worth of it, because of course the borrow must be over collateralized. So you have to put the collaterals that in value is way higher, as we will see, to the money that you want to borrow. Why this? The same example that we did earlier with Alice and Bob, to avoid that you take the money. And of course, what happens if you, for example, deposit 8,000 worth of it, and for example it goes down in price, the protocol becomes insolvent, because now the person has more money than what it has deposited. Instead, the protocol wants that you deposit tokens with over collateralized, because if this goes down in price, let's say this goes to 10,000, still the protocol has margin, so it is not insolved, sorry, and it is not losing money. Okay. Now we will see this all in greater detail. Let's start, since we have talked about APY. What is the APY? APY means annual percentage yield, and this shows how much you earn or pay in 1 year. This includes compounding and represents the final result after 1 year. It applies, of course, to both lending and borrowing, as we've seen this. Then we will also see this in the Aave application. Why? When API is useful for long-term position, understanding the final returns and comparing yields across protocols. So for example, if you supply $1,000 with a supply APY of 5%, after a year you have $1,050, so you earned $50, assuming that the rate is the same. Then we also have APR, annual percentage rate, that shows the yearly interest rate, but in this case does not include compounding, and represents how fast the interest is accruing. This is useful for short-term analysis, understanding interest rates charts, and tracking rates changes over time. An example is very similar. If you supply $1,000 with an APR of 1.44%, after 1 year with no compounding, you earn $14.4. So the total money that you have is $1,014.4. So the basic difference between the two, it is that this is an example made with an initial deposit of $1,000, an interest rate of 10%, and time of 1 year. So as you can see, the formulas are different. So in this case, there is no compounding. At the end of the year, you get $1,100. In this case, there is compounding, so you get a little bit more, because of course you are earning considering also the interest that has accrued. Now let's talk another important topic here, which is loan to value. Loan to value means basically the ratio between the loan that you take and the value that you provide as collateral. So this basically tells how much you can borrow against your collateral. Let's make an example. For example, if it price is $2,000, you deposit one ETH, so your collateral is of $2,000. The max loan to value is 80%, so you can borrow up to $1,600 dollars of USDC. The maximum that you can borrow will be $2,000 times the max loan to value, which is 80%, so 0.8, which is $1,600. So the concept of liquidation threshold is very important. The liquidation threshold is the point where your borrowed position is at risk of liquidation. What does it mean? So we have this ratio, loan to value. If the value of the collateral, for example, that you have provided, for example, it goes down, or the loan goes up, your loan to value ratio will increase. This means that you risk to be insolvent. So the platform goes at risk. And so let's make an example to understand this better. Let's say that we have a liquidation. Let's imagine we are at time 0. We have a liquidation threshold of 83%. Our ETH price is 2,000. We have deposited one ETH as collateral, so the collateral value is $2,000, and we borrow $1,600. So our loan to value is, if we do the math, $1,600 divided by $2,000, it is 80%. So it is below the liquidation threshold, which is 83%. Let's imagine that at time 1, so later on in time, the ETH price falls from 2,000 to 1,800,000, sorry, 1800,000. Sorry, 1800 goes to $1,800. The loan to value in this case will be 1,600 divided by 1,800, which means we have a loan to value of 88.8%. So we are above the liquidation threshold, so our position becomes liquidatable. We can be liquidated. This concept is related to the health factor. So the health factor, it is this formula here, and is the collateral value times the liquidation threshold divided by the total borrowed value. It is so very related to this liquidation threshold. This basically is a number that we will see later on in Aave, when we will be using Aave. It allows us to understand how our position is safe. So if the health factor is greater than 1, we are safe. If the health factor is equal to 2, we are at the liquidation threshold. So we are basically we are at this threshold here at 83%. If the health factor is lower than 1, we are liquidatable. Let's make an example. So as we said, this is the same example as before. So at T0 we have a liquidation threshold of 83%. It price is 2000. We deposit one ETH, $2,000. We borrow $1,600. So our health factor will be 1.03. So we are safe in this case. But if the ETH price goes below uh, under $2,000 to $1,800, the health factor goes to 0.93, so we are liquidatable. What means to be liquidated? Liquidation, so as we said, happens when a borrower's health factor falls below 1. This means that the collateral that we have provided no longer safely covers the borrowed amount. This can happen in two instances. For example, if the collateral value decreases or if the borrowed amount increases, the protocol allows liquidators to step in and reduce the risk. So let's see step by step what happens. So for example, a liquidators can, since we are in this situation, so our health factor is lower than 1, a liquidator can repay part of our debt. So let's say that liquidator wants to pay part of the borrower's debt, for example, 500 USDC. Now the debt is it has been reduced from 1600 to 1200 dollars or USDC. I'm talking about USDC or dollar, but in this case it is the same for me. Step 2, the collateral is taken with a penalty. So as we will see, there is a liquidation penalty bonus of 5%, which means that the liquidator receives $500 times 1.05 because this consider this penalty liquidation. So it gets by paying $500, the liquidator gets $520 worth of it. So with a wide liquidator is incentivized um, to to act in the protocol, so to buy this bad debt because it earns this liquidation penalty. So let's say that as we said, the it price was $1,800. So the borrower in this case loses 0.23 it, okay, which is um, the exact amount of it that the liquidator receives, and it loses collateral. So basically, the borrower loses the collateral that has provided to the protocol. In the end, it will he had one hit in the end minus the 0.23 um, collateral of it that he has lost. It will end up with 0.76 so we can say that what is important for us is that we don't want to be liquidated, so we want to avoid this liquidation as much as we can. So during the liquidation process, the borrower experiences this, loses part of the collateral, pays a 5% liquidation penalty, but the debt is reduced and the positions moves back towards safety. For what concerns the liquidator, it repays part of the borrower's debt, receives a collateral in return, gets a 5% liquidation bonus. So now let's go to the Aave platform. Let's understand how this works in practice. So in this case, I'm on the base mainnet. You can choose whatever chain you want. I wouldn't do it. I'm using also Aave V3 here. I wouldn't use Ethereum mainnet because of course the gas fee are higher. I'm using Base, but as you can see here there are a bunch of layer 2s like Arbitrum. There is also Polygon, ZK Sync, whatever. But I will be using Base. So as you can see here, you can find all the asset that you can provide uh, to the protocol. As a lender, if you want to lend tokens to the protocol, or that you can borrow from the protocol. You have a bunch of tokens here. You can deposit, for example, Ethereum, USDC, EORC. This is a Go token. This is a stable coin of Aave. Aave token. There are a bunch of tokens. Maybe if you go to other network, for example, here Arbitrum, you have other tokens that are supported here. That was, for example, here USDT 0. That are not support, or Chainlink that maybe are not supported in the other chain. Nevertheless, let's say that we want to deposit Ethereum. So we go here. Here it gives us all the details about Ethereum. So here we can find a bunch of metrics. First of all, here we have the reserve size. This represents all the funds deposited by the lenders, whether they are currently borrowed or not. So it is the total supplied asset at the current price. So the current price of Ethereum, for example, is $3,000 and $1,000. As you can see here, the reserve size is identical to the total amount of tokens supplied. So this basically is the amount of Ethereum that has been lended, that has been deposited in the protocol. Why we see here Wrapped Ether? We see Wrapped Ether because, of course, Aave works with ERC20 tokens and cannot work directly with Ethereum, which is the native currency of the of Ethereum. So it basically wraps Ethereum into Wrapped Ether, so it is ERC20 compliant and can be used in the protocol. But basically, the value of Wrapped Ethereum or Ethereum, it is exactly the same. So this is the first metric. Let's talk about this second metric here, available liquidity. Available liquidity means it is basically the difference between total supplied token and the total borrowed token, and this means how much of an asset can be borrowed right now. In fact, if you make the difference between the reserve size, which is 353 54, let's say, more or less, $1 million minus this value here, okay, you get this value here, the available liquidity. Another important metric here, it is the utilization rate. The utilization rate is basically the ratio between the total amount of borrowed tokens, this one, and the total supplied tokens, this value here. This is a good utilization rate, but this is important because for the interest rate model that Aave uses. Because if the utilization rate is low, as you can see, the the borrow APR, so the interest that you get when you borrow money is lower. If the utilization rate reaches this 90%, after this value it grows very with the speed uh, line. So the borrow interest, the borrow APR increases really fast. So we if you want to use this protocol to borrow money, you should stay, of course, in the a utilization rate that is, let's say, below 90%. So you have to pay lower APR. Instead, if the utilization rate goes beyond 90%, the interest that you have to pay, the APR that you have to pay will grow, will increase very, very fast. And this is used to avoid that the protocol runs out of liquidity. So another metric that we need to talk about, it is here. As you can see, this is the cap, and this is in token value, Ether value. This is in dollar value. This is how much the maximum amount of token that it is possible to deposit. Once you reach this limit, no new deposit are allowed, and but the 16 users can still withdraw. Instead, here there is another cap which is referring to how much of an asset can be borrowed. So this is the maximum value that can be borrowed. After when we reach this value, no new borrowing is allowed, and but existing loans continue normally. Okay. Now we can also understand the difference that we were talking about earlier a little bit when we're talking about the difference between APR and APY. As you can see here, this is an estimation over a year how much you will earn, and it takes into account the compounding effect, so the interest that you earn each day, while this is an estimation of how let's say the pool is going right now. And typically the API is always greater than the APR. So, but it's important for us, it is the API, so we can know, let's say, a year from now, how much interest we will gain when depositing funds. Here, how much we will pay when we borrow these funds. Another important difference is this difference here. So, when you deposit funds, you gain 1.41%. When you borrow money, you have to pay 2.16%. Why is that? This is because Aave takes a small cut of interest. This has to do with the reserve factor here. Because of course a small cut of interest is paid by the borrowers, is kept by the protocol, and is stored in the protocol reserve. This protocol reserve is used to cover bad debt, protect lenders, improve protocol safety, fund the development, and support the ecosystem. So this is why we have this difference here, because mainly Aave takes these funds for reserve and also to support the development. Now you can see the here the metrics we were talking about earlier. So the maximum loan to value that you can um, this is the maximum amount that you can borrow. So if you can borrow the maximum of 80% of the collateral that you provide, and the liquidation threshold is 83%. Of course, it is higher than the max loan to value, so the maximum that we can uh, borrow. And there is a liquidation penalty in the case we get liquidated. So that's why we have explained all this concept before. Another thing that we will see here in Aave, in this case in Ethereum, is that as you can see here, it correlated asset like um, in this case RS, IT, VRST, IT, whatever. These are all IT related assets. As you can see, they have a liquidation threshold and uh, a max loan to value very high because of course they have a price related to Ethereum, so it is basically the same asset. So uh, if you borrow against this collateral, you there is less risk. So you also pay a lower liquidation penalty. You have a lower liquidation threshold, and you have an higher loan to value maximum. So let's try to use the platform here. Let's start by connecting. I have already this wallet where I have $5 of Ethereum. I'm on the base mainnet. Let's connect the wallet. Okay, I'm connecting. Okay, perfect. Now I go to the dashboard. It recognize that the asset that I have in my wallet is Ethereum. Okay, I want, for example, provide this asset as um, I want to lend this asset to the protocol. So I'm acting here and now as a supplier, as a lender. Let's hit here supply. I want to the maximum that I can supply here is $2 worth of it. Okay, let's supply this it. Let's see what happens. Okay, this is the transaction, the network base. The method is deposit it. Okay, these are the parameters of the function that you are calling. Of course, the gas fee should be very, very low because we are on NL2 on base. So I confirm. Okay, I can view the transaction here. No, sorry, this is let's see it on the okay. The transaction is very okay. Now I can see it. I wanted to see in the base scan. Okay, this transaction. So we basically have transferred this money. Uh, in this transaction, there is the value that we have provided. Okay, we are calling the deposited function from our wallet. This is my wallet, 75 to b 75, okay, to b. This is my wallet, and I'm calling the deposit function on the Aave wrapped token gateway. Okay, that also basically does two things. The first things is that it gives us this Aave base wet, and it takes the wrapped ether. So if I go to my portfolio, I can see that now I have an equal amount of the ETH that I have deposited in the platform. Okay, close. So here it is 0.3062 whatever, and it should be an amount similar to this. Um, why I get so I have the platform is taken from me $2 worth of it. In fact, I had $5. Now I have $3.1, and has given me this almost $2 of Aave V3 wet. This is another token, rebase token, which basically is used by Aave for to to calculate your interest. So basically, this token is used by Aave to um, um, so in this token, with this token, Aave V3 wet, Aave takes tracks of your accrued interest. Okay, so it is a token created by Aave. Um, and it should grow in value over time because this accounts for your APR that you have accrued. Okay, so once we have done this, we can of course now we have provided this asset. This is the asset that we have supplied, as we can see here. This is the value of the collateral. This is the APY that we are expecting to earn after 1 year. Now we can borrow asset against this collateral, which is $2. Okay, more or less. So let's say that we want to borrow USDC. Um, the APY, sorry, that we have to pay is 3.71%. But if we look deeper here, we can see that the real cost is 5.73%, and these are merit incentives. Which means that basically the protocol is paying you some tokens, amount of tokens, and to let's say incentivize borrowing this USDC, and so for this reason the total API would be 3.71%. But this is it's not you have to be eligible, and it is paid in another token, which is AUSDC. These merit incentives. So depending on if you are eligible to get these incentives, your total API could be 3.71%, but normally your protocol the cost of borrowing USDC would be 5.73%. Okay, so if we want to borrow this, we say, for example, maximum. As you can see here, here it already calculates us the health factor, which is 1.04%. 1.04. The liquidation is below 1 health factor. So here we are already at risk. So we want to borrow a little bit less, let's say 1.4, to have. As you can see, as we borrow less, our health factor gets greater. So if here I put, for example, 1, it's 1.6 USDC. Okay, let's borrow. This is a good health factor. We want to keep it, as we said earlier, as as higher as possible and not close to 1 because we are at risk of liquidation and we lose part of our collateral. So we borrow this USDC. Okay, we are calling the borrow function. Okay, we confirm. Okay, let's review the transaction details. Okay, so in this case, we have received $1 from the protocol. Uh, let's check out here what we have. So here we have our $1 USDC, okay, that we have received. And now with this money we can do whatever we like. We of course we can do whatever operation we want. Now it should also update this dashboard here. So as we can see here, we have our USDC, $1. We have also seen it in our wallet, and we are paying to borrow this asset an APY of 3.72%. This is as we said uh, as we said earlier, here we have the sorry, I was saying this is in reality is 5.73% because this takes into account the rewards, the incentives that the platforms gives you, but the borrow power used is 74.3%. Why? Because we have chosen to borrow a little bit less than the maximum to avoid being a risk of being liquidator. Here you can see also the metrics. You can see that of course the health factor here is 1.6%, and this is basically it. So now with this USDC you can go to do whatever you like. You can, for example, supply it to Aave. You can swap it for with Uniswap for Ethereum and deposit other Ethereum. So doing some leverage, you can do whatever you like now with this USDC. Now to go back, if we want to retrieve our money, we should here repay our borrow. Okay, we say maximum amount. Approve USDC to continue. Okay, here is calling approve. Let's confirm. Okay, approve and continue. So now we can repay our USDC. Okay, confirm. Review transaction details. Okay, of course, here we are giving back our USDC, and all this transaction we should see all here in our in the block explorer. So this is the repay transaction, the two approve that we have repaid our loan, and this is the borrow that we have done before when we have taken one USDC. This is here we have deposited the it into Aave, okay, Of course, these are approving function because we are interacting with the USDC token, so it always calls the approve. So for some reason there is a very low part, very small part of USDC that has not been repaid. Let's try to withdraw our it. So let's put here withdraw maximum, withdraw. Okay, now we are withdrawing it. Confirm. Okay. It is completing the transaction. Okay. It's given us again 1.94 worth of it. So we should see again here. Okay. 5.03 dollars. Thanks for watching this video. If you have any questions or suggestions for other videos, please drop a comment below and see you in the next one.